Your observability stack is running. Prometheus is scraping. Grafana is visualizing. But do you actually understand what's happening inside? In the next 10 minutes, you'll learn how Prometheus really works. This knowledge separates engineers who copy dashboards from engineers who build them. Let's open the hood and look inside Prometheus. Prometheus has three main components. First, the retrieval engine. This is the scraper. Every 15 seconds by default, it reaches out to your applications and pulls their metrics. Not push, pull. This is fundamental. Second, the TSDB, time series database. It stores every metric with a timestamp. Incredibly efficient, a single Prometheus can handle millions of time series. Third, the HTTP server. This is the API layer. It runs PromQL queries and serves the UI. Grafana connects here. The key insight: Prometheus is in control. Why does Prometheus pull instead of push like other systems? Three big reasons. 1. Control. Prometheus decides the scrape interval, not your app. 2. Health checking for free. If a scrape fails, Prometheus knows the target is down. 3. No flooding. Apps can't overwhelm Prometheus by pushing too fast. When to use push? Short-lived batch jobs. That's what the push gateway is for. But 95% of the time, pull is what you want. Every metric in Prometheus is one of 4 types. Master these and you understand monitoring. Type 1, counter. Only goes up, never down. Think, total requests, total errors, total bytes. When the app restarts, it resets to 0. That's expected. Critical rule: never look at a raw counter value. Always use rate to get per second increase. The current value, 1 million requests, tells you nothing. 100 requests per second, that's useful. Type 2, gauge. Goes up and down. Think, temperature, memory usage, queue size, CPU percent. Use it for current state. CPU is at 80% right now. No rate function needed, the current value is meaningful. Type 3, histogram. Counts values in buckets. Perfect for latency. You get buckets like requests under 100 milliseconds, requests under 500 milliseconds, plus sum and count for averages. The magic: calculate any percentile later, 95th, 99th, whatever you need. Use histogram_quantile function. This is the most powerful metric type. Type 4, summary. Pre-calculates percentiles on the client. Less flexible than histogram, you can't aggregate across instances. Being phased out. Prefer histogram for new metrics. Decision framework. Counting events. Counter. Current value. Gauge. Measuring duration. Histogram. Good naming is the difference between finding and losing your data. Naming rules. Snake case, lowercase with underscores. Include units, seconds, bytes, total. Prefix with namespace. Prometheus _, node _, HTTP _. Good examples: HTTP _requests _total, node _memory _bytes. Bad examples: HTTP requests in camel case, request _time without units. Now labels: this is where Prometheus gets powerful. Instead of separate metrics for get and post, you have one metric with labels. HTTP _requests _total method equals get. Status equals 200. HTTP _requests _total method equals post. Status equals 201. Every unique label combination is a separate time series. That's dimensional data. But warning: high cardinality kills Prometheus. Never use user ID, request ID, or unbounded values as labels. A million users equals a million time series equals dead Prometheus. Let's see this live in our cluster. Port forward to Prometheus and open localhost 9090. First, status, then targets. Here's every target Prometheus is scraping. Green UP means healthy. Red down means problem. This is your first debugging stop. Is Prometheus actually scraping your app? Check the last scrape time and any errors. Now the graph page. Type up, execute. The up metric is built in. 1 means target is alive. 0 means down. One query shows all target health instantly. Now type Prometheus _HTTP _requests _total. See the labels, handler, code, each combination tracked separately. This is dimensional data in action. Finally, status then TSDB status. How many time series? How much memory? Chunk count? If these numbers explode, you have a cardinality problem. Watch the head series count. That's your active time series. How does Prometheus know what to scrape? In Kubernetes, Prometheus watches the API. Automatic discovery. Add these annotations to any pod. Prometheus.io/scrape equals true. Prometheus.io/port equals 8080. Prometheus.io/path equals metrics. Prometheus sees the annotation, extracts the port, and starts scraping. No config file changes needed. Pods come and go. Prometheus adapts automatically. This is the magic of Kubernetes service discovery. 2 critical settings to know. Scrape interval, default 15 seconds. Lower means more data but more storage. 15 to 30 seconds is production recommended. Retention, default 15 days. Older data deleted automatically. For long-term storage, use Thanos or Mimir. Both settings tunable in Prometheus config or Helm values. Let's recap what you learned. Pull-based architecture, Prometheus is in control. Not your apps. 4 metric types, counter for totals. Gauge for current values. Histogram for percentiles. Summary being phased out. Labels for dimensional data, but watch that cardinality. Kubernetes service discovery, automatic target detection. Scrape interval and retention, tune for your needs. Next video. PromQL, the query language. You'll write queries that power dashboards and alerts. Rate functions, aggregations, histogram percentiles, the real power of Prometheus. Subscribe so you don't miss it. And if this helped you understand Prometheus better, hit that like button and comment which metric type you use most.